Okay, so now I'm going to go through this problem a little bit step by step. So the first thing it says that a homeowner pushes a 20 kilogram lawnmower with a constant velocity. Her arms make an angle of 45 degrees with the ground, and the effective kinetic friction on the lawnmower is 58 newtons. So the first thing we need to do is draw a free body diagram. But I also want to point out also here that it says constant horizontal velocity, which means zero acceleration. So all of the forces are going to be not equal to ma. Well, mostly because a is 0, so the sum of all the forces is going to be equal to 0 in the horizontal direction. So we want to first do a free body diagram. This is a picture of the lawnmower and the 45-degree angle that I'm trying to indicate here as a force against the lawnmower. Now, when we do this, we want to look at who is it that we are, what object are we looking at, and then translate all the forces into forces coming out of a point that indicates the object. So we're going to say it's the lawnmower that we're interested in, and so there's this point here that we're indicate as is the lawnmower. The first force we're going to put on there is the 45-degree pushing force from the person. The next I'm going to put on there is it says it's a 20 kilogram lawnmower, so there's some weight associated with it because of gravity, and we know that's the mass times the gravity. And then there's also a normal force, because there's always a force. If something's on the ground, it's going to be a normal force that's pushing up. And then lastly, there's a kinetic friction, which means that kinetic means moving. So there's a moving friction force, and the friction is always opposite to the motion. So in this case, the friction is pushing back here, the motion is going this way, and the friction's going back there. So now we have all of these forces, and this is a free body diagram. And another thing sometimes that's written on here is that we put F net equal to 0, so we know which way acceleration, if it's going any particular way. In this case, it's going to be equal to 0. So the next thing we want to do is take this force that's at this 45-degree angle and make it into two forces, one in the x direction and one in the y direction. In that way, we can then look at those directions separately. And now the way we're going to do that is knowledge about cosines. And I'm indicating the angle, even though I didn't write it here, I should have, that it says 45 degrees right there, because it says it's 45-degree angle with the ground. So this is the ground and this is her arm, or the way that she's pushing. So if we look at a cosine of an angle, theta is equal to the adjacent, this is the x direction, over the hypotenuse, which is the force. So we can then go ahead and solve for f of x, and it's going to be force times the cosine of 45. We can do the same thing in the y direction because it's equal, again, this is the angle, so it's opposite over hypotenuse, and that will give us a force in the y direction is equal to force times sine of 45. So now what we've done is we've took this force and we broke it into an x force and a y force that's equivalent, and now we can redraw the free body diagram where we have things going only in the x and in the y direction. So now we can isolate the x direction, and we can write the equation where we take this value here and this friction value here, and we can say that the friction, which is in the positive direction, minus this force is going to be equal to 0. Now we know that because there's constant horizontal velocity, so all the forces have to equal 0. And then if I just do the math associated with it, I get the force, this force, which is that force in the downward direction, F, is 82. Now I'm going to isolate in the y direction, so I'm going to take only these forces that are in the y direction and write an equation for it. So I have the normal force, which is a positive, minus the weight, minus the sine of 45, which is this portion of that pushing force here, and that's equal to 0. And then I know the weight is 20 kilograms times the acceleration of 9.8, and I know from the previous thing, F from the previous y direction, we have F of 82 times the sine of 45. And I can reconcile that so that now the normal force, which is what they're asking here, is 254 kilograms. Anyway, I hope that helps.